Hello everyone, my name is Advait and welcome to my YouTube channel. So today we're going to be talking about IGCSE additional mathematics. In particular, we will be talking about the chapter 8 circular measure. So let's start. So this chapter is all about radian measure and solving problems involving arc length and finding the area of a sector. You should already know how to find the length of arc AB or finding the area of sector OAB as shown in this question, right? So, but however, if you don't know that, it's still fine. It's not an issue. So I'm just going to zoom in here. All right. Hope you can see this question. There is an arc here and there is a side OB and OA. OA is given by 5 centimeter and this this angle is given by 48 degrees. Alright, so let's start from scratch. So we have talked about many topics in this chapter. Basically we also talk about arc length. An arc equal in length to the radius of a circle subtends an angle of 1 radian at the center. It's fine if you don't know these terms, and honestly, it's not a bit. It's very easy to understand them. So, but right now you might not know them. So let's start from the scratch. Okay. Arc. So let's start. Okay. So what is length? So length. When we talk about length. Length is basically if you have this point A and you have this point B. So the distance between these 2 points, between these 2 points can be called as the length. Here we can call this as the length. This is the length. Length or distance can be anything. Now if you have a curve in the length, or if you have a line which is curved, then we call that as the arc. Okay, we call that as the arc. Arc is basically if you have a line which is curved. So if this is a curved line, we call it as an arc. Okay. Now you have concepts of a circle. So if you, what the circle is basically, we all know that a circle has 360 degrees, right? So let me start with that. Okay, so let me just take a circle here. Might not be perfect, but you can kind of understand it, right? You have the center. Center is basically the coordinate or the point which is at the middle. So middlemost meaning if you take the distance from anywhere in the circumference of the circle. Circumference is basically this outer line of the circle, right? So if you take, let's say I'll take this point. So the distance between this point to this point must be equal to the distance between this point to this point. So both of these, I'm just gonna say, yeah, so both of these must be x. It can't be x and this, it can't be like this one is x and this one is y, because that won't make sense. In a circle, basically, the length between between the point on the circle and the center should be the same. That's called the radius. So earlier in the ancient civilizations, the Babylonians were the first ones who divided the circle into 6 equilateral triangles, and then they subdivided each angle at O into 60 further parts. If you look in this, so this is a basic circle, okay, and you can see that there are 6 parts, 6 triangles in this, and the center is O. That is how the concept came up about the revolutions of 360 divisions in one complete revolution. 360 has many factors which can make division of the circle much easier. So we will discuss about this later. And one more fact is that degrees are not only the the measure of circles or the measure of angle. There are also other units. So let's say if you have this angle, so mostly we use a protractor to find the angle, and we mostly know that this might be 30 degrees or it might be 45 degrees. But did you know we also had a unit called radian? Yes. So basically, radian is all just like the other units. Like how you can convert from kg to lbs or pounds. Yeah, so just like that, kg and pounds are two different units, but for the same concept. Just like that, radian and degree are different units, same used for the same concept. So you can say that 30 degree is equal to some radian. It could be equal to x radian. Radians are always expressed in this form, x raised to c. It's not x raised to c, but it is represented as x and c is on the top right. So 30 degrees can be equal to x radians. We have to find that x. We will learn about that later. Okay. Now one fact is there, an arc equal in length to the radius of a circle subtends an angle of 1 radian at the center. What does this mean to say? So let's draw it. Okay, let's learn about it from the start. Right. So here let's draw a circle. I'm just gonna draw. That's the best I could do. Let this be the center, and let this be the radius. Now this is also a radius. Now this angle is 1 radian. Okay, remember 1 radian. I said 1 radian. Okay, and let the radius be represented by r. So I'm just gonna draw r here. And this, what we see here, this is the arc. This is the arc. Now, the fact, what they're trying to say in this sentence, what they're trying to say in this sentence is that an arc equal in length to the radius. So if this arc is equal to the radius is represented by r. So that means the arc is also r. An arc equal in length to the radius of a circle will subtend an angle of 1 radian at the center. So that means if you have an arc which is equal to the length of the radius, then the angle made will be 1 radian at the center. That's it. Okay. It follows that the circumference, an arc of length 2 pi r, subtends an angle of 2 pi radians at the center. Same logic is there basically. So basically, if this statement is saying, it follows that the circumference, an arc of length 2 pi r, subtends an angle of 2 pi radians at the center. Meaning, what we can say with this statement, we can say that 2 pi is equal to 360 degrees. If so, then pi is equal to 360 by 2. So then pi will be equal to 180 degrees. And pi radians, as I said, pi radians. So here we know the concept of conversion. So now if we have 180 degrees, we can say that it is equal to pi radians. That is how math works, and I think that's the beauty here. Converting from degrees to radians. So the same concept is there. Since 180 degrees is equal to pi radians, as we discussed here, in that case, if you divide this by 2, then 90 degree. So a 90 degree angle will be equal to pi by 2. Okay, let me just erase this. I'll draw it differently. Okay, here you can see. In that case, we can say that 90 degrees is equal to pi by 2. radians. There you go. So then if pi by 2 is equal to 90 degrees, pi by 2 radians is equal to 90 degrees, then again 90 by 2, in that case that will be 45. So 45 degrees is equal to pi by 2 into 2. So pi by 2 into 2, so that will be 4. Pi by 4 radians. So like that you can go forward, right? So now you divide 45 by 2 and all, and that goes into decimal. So okay, that goes on forever. Angles that are not simple fractions of 180 degrees can be converted using the following rule to convert from degrees to radians. Yeah, so this is a very good point. So you can just remember this. So if you want to convert from degrees to radians, so if you have a set degree, okay, and you have to convert to radians, what you will do simply is, what you have to do is that multiply the degrees with pi by 180. How though? Like this: degree times pi by 180. Please remember this. This is a very good point, and I think if you remember this, then it will be a very good help for you also. So you should always remember this point. That degree times pi by 180 will convert it to radians. Now if you want to convert from radians to degrees, right, if you want to convert from radians to degrees, I'm just gonna go here. If you want to convert from radians to degrees, you will do it like this. So radian, radian, let it be in brackets, times 180 divided by pi. This will give you in the form of degrees. This is how it is, and I think this is very easy to if you want to memorize it or something, it's very easy. It's not very hard, and it is very useful to remember that 1 radian is always equal to 1 times 180 by pi, which is 57 degrees, equivalent to 57 degrees. Please remember this, because if you can remember this, no, you won't have to memorize many of the formulas. You won't have to use them. Only one formula can help you. What is that? 1 radian is equivalent, the sign of equivalency, or is very near to, is this. So equivalent to 57 degrees. So actually it's not exactly 57 degrees, again it's something around 57.32 something. Okay, so now worked examples are there. We're gonna leave that. Let's start off by doing the exercise. So in this video we will try to complete the exercise. So there are 6 questions for your whole exercise, so it's not that hard. I think let's do the whole exercise. 6 questions are there. Okay, let's start. So question 1 is there. Question 1 is saying A part 10 degrees. So convert these angles to radians. Again, as we discussed, 10 pi by 180. Now very good thing to remember is that always when you have multiplication on the numerator and at the denominator you have some unit, you can always cancel out, which is the best thing you should do. So pi by 18 radians is going to be your answer, as they're saying in terms of pi. It's the best thing to do. So now we have pi by 18 radians. Okay, then if you have B part, so 20 degrees. So again 20 times pi by 180. In this question, let's cancel out the zeros. Then 2 ones are 2. 2 times 1 is 2, and 2 times 9. So easily we get pi by 9 radians. There you go. There you go. Okay. Then I'm just gonna move forward with this. Okay, if you have, let's say, the C part. obviously we have the C part. So 40 degrees, again 40 degrees, we can write it as 40 pi by 180 radians. That will be we can't cancel it out directly, so we can write this as 2. We can write this as 9. So 2 pi by 9. Alright. We can do one more thing. We can write this as pi by 4.5. But I think this will also work. It's not a hard and fast rule. But okay, you can write any of these two answers. I think they must accept both of them. So both of them are fine. Okay. Now let's go forward. Now we have D part. D part is again 50, so 50 pi by 180. I think these questions are very simple and you might be able to do them because there's nothing very hard with them. They're mostly the multiples of 5, so it is gonna be easy. And plus 180 is it's also a multiple of 5, so it's very easy to solve. I am gonna do let's do the last parts, the last which might seem hard. So okay, we have some, like we have 9 degrees, 75 degrees, so they are good questions. I think we should do 135 and 9. We'll do G and M. Okay, I won't do D part, I will do G and M. If you understood A, B, C, then you will be able to do D, E, F easily. There is no you must be able to do them. There can't be any confusion. G part, maybe we should check it out. Okay, 35 pi by 180. One more thing is, this question might come as a not calculator one, so I am not going to use calculator. I will try my best not to use the calculator in this exercise, but if I have to, then we will see. 135 pi by 180 is there, right? So 135 pi, we can directly write it as, okay, 135, let's divide it by 5. So 5 2s are 10, pi times 2 is 10. We'll write 5 times 2 is 10, okay? 3, and this we get here. We times 7, so we get 7, right? Then we write here 35, we get 0. 27, okay, no problem. 180 we have, 180 we can also divide by 5, okay. 3, 15, we get 3 here, so 0, 6, we get 36. Okay, no problem. We can not simplify this anymore, right? So if you cannot simplify it anymore, then you can just write it as 27 pi by 36. There is nothing wrong with the answer. Okay, you can write this as 27 pi by. However, if they're asking you to do it even better, then I think you should do this. You should divide 36 by 27, and that is the best way to get the perfect answer. So you will get it something like this, pi by some decimal number you will get. So that will be your correct answer. But in this case, I think this can be the answer. Okay, now let's do the next part. So our next part is okay, yeah, 9. Oh, this is actually not that hard. So 9, I shouldn't have chosen this actually. 9. So this is very easy. So pi by 20 is your answer. Very easy, okay? Nothing hard in this. So if you have any doubt in any other parts, you can always comment and you can always tell me that you have a doubt in this part, and I will be ready to help you out there. Alright? Let's just erase all of this. Okay, let's do the second question. Okay, seems good. Okay, this is also very easy because you have to convert to degrees. Okay, always multiply by 180 by 6. Not very hard, but okay, fine. Let's do it. Again, I will do the A part first because you have to make it as easy as we can. Pi by 2. Okay, now you have to be very cautious. Pi by 2 is already there. Okay, pi by 2. Sorry for this. Pi by 2 times 180 by pi. You have to do it like this. So now in this case 2 times 1, 2 times 9. So 90 pi by pi. Pi can cancel it out, can cancel itself. 90 degrees is your answer. So please be cautious about these questions because they are meant to confuse you. Okay. No, this question is easy. Yes, this question is definitely easy. It was not very hard. 90 degrees is your answer for this question. But however, you have to be cautious with other questions because maybe when you are in a hurry, right, you might mess up. And we don't want that to happen. Let's quickly do the other parts. I will not waste a lot of time. I won't do the B, C, D parts. Let me do other good questions. Let's do H part. Do H part, H and N. So 75 degrees is your answer. Alright, there you go. We have completed a lot of the second question. Yeah, I have done the G and N part for you. I think you will be able to do the other parts by your own. Now we have to convert these angles. The third question, you have to convert each of these angles in radians correct to three significant figures. Alright, no problem. Okay, so let's do the question 3. Alright, so okay, they're asking to do it in three significant figures. We will use a calculator for that. So let me use a calculator. I used try to yes, okay. So we can see this. We have a calculator here. It's a standard calculator. 8 pi by 45. 8 times we want pi here, right? So scientific we can make it 8. Okay, no, sorry. So 8 times pi. 8 times pi. 25.1327. Alright, no problem. We don't want these many digits, but okay. 25.13. Okay, fine. 28 times by 45. Divided by 45, we will get 0.585. We will just write that down here. 0.585, I think. 0.558. 0.558 is gonna be our answer. Okay, samely you'll use a calculator. So let us do the E part now because it's a harder. 247 pi by 180, yeah. All right. Okay, this is interesting. Now in this you can directly use it in a calculator also. That is also okay. Nothing bad in that. You just have to do it. Yeah, good. Okay. Okay, yes, switch. 247 times pi. Okay, 247 times pi we will do. So 775 and then divided by 180. 4.3109. Okay, 4.31 you can write. Yeah, we will write 4.31. 4.31 is going to be your answer. Okay, there you go. Okay, now let us do the last questions that are in this exercise. Might seem hard. Okay, you have to use a calculator, right? So I think you write each of these angles in degrees correct to decimal place. I do the last part also in this. The part 0.58 times 180 by pi. Simple. You will see 0.58 times 180, whatever you get, divided by pi. 33.23. 33.23. Okay, one decimal place. Okay, 33.2 then we can write. Yeah, 33.2 we can say. There you go. That's your answer. Alright. Yeah, let us go. And okay, so this fifth question is also similar. We have to complete the table. Copy and complete the tables, giving your answers in terms of pi. So degrees is given. I have to convert it to radians. The same concept is given. I do not think I have to attempt this question. If you guys think that this question is to be explained, then you can always comment and I will create a separate short to explain this concept. Okay. Okay, now let's quickly use the sixth question. Do the sixth question. Now, sixth question is actually very, very tricky. Why tricky? I'll tell you that. Use your calculator to find a part. Sine 1.3 radians. Say. If you go to your calculator normally, it will tell you in degrees. Okay, it will tell you in degrees. Please remember that information. It will always tell you in degrees. So there is always a way to convert it. So if you have like you will have this DEG. So this says degrees. Click on it and it will convert to radians. Now you can easily uh, now you can easily do this. So sine pi by 2 is there. So sine pi by 2 radians might be. Okay, yeah. Okay, they haven't told here. So D is sine pi by 2 degrees or radians. We don't know that. Okay, but we can convert to radians, and now we can do trigonometry. So trigonometry, you should know the basics of trigonometry. If you do not know, then it's fine. Whatever they're telling you here, just do that. Okay, sine 1.3 rate. So just do sine. Click on sine. Okay, sine 1.3. And okay, no, I think I messed up. Yeah, sine of 1.3. You get? Okay, no, there must be some issue. Let me do it on my scientific calculator. You want to convert yourself, so you on your scientific calculator, if it's a FX991 ES plus, click shift and then mode, and then click the number 4. That gives you in radians. Sine 1.3 is equal to 0.9635. Okay, so this is not working. We'll close this. So sine a part, sine sixth question, a part, sine 1.3 radians, okay, is equal to 0.96. We can write 0.96. Okay, b part, we can say tan 0.8 rad. So tan, so these are just functions of trigonometry. Okay, I will be explaining this also. Trigonometry is a very good concept, and I think we all should know about trigonometry. It's very fun, and I enjoy trigonometry a lot. I think you will also. So again, I'm just gonna click on tan. Then you want to click 0.8, not click. Sorry, type 0.8. Okay, and you will get 1.096, 1.0296, 1.0296, 0.3 we can say. We can say 0.3. There you go. Now let's do the... Okay, now let me come quickly do the D part. D part... okay, I'll do the D part and E part. Yeah, I'll do the D and E part, alright? Tan, I think you must have understood because we just did that. So D and E part will do. Sine pi by 2, pi by 2, pi by 2 must be in radians only, I suppose. So it is fine. Okay, tan pi by 2. Okay, tan pi by 2. So here you have to use a little bit of your wit. And tan pi by 2. Okay. Oh, sorry, it's sine pi by 2. My bad. Sine pi by 2. Pi by 2 is 1. Okay, very simple. Now let's do E. E is going to be cos pi by 3. Cos pi by 3. Okay, cos we have pi by 3. 1 by 2. 0.5. There you go. That is how you will do the exercise 8.5. Thank you so much for watching this video. I hope you had understood the concepts, and I am myself an IGCSE student, so I am still learning. However, I will try my best to explain you all the concepts that are in the IGCSE additional maths, and this is all we have done today. So yeah, good work. Thank you so much, and I'll meet you in the next video. Bye bye.